Right, so I'm gonna start the presentation. Yeah, so yeah, I'm gonna talk about the DeepQ network. This slide was originally the lecture that I made in the Denver Quant Society. I decided to make a recording because it's going to be repeatable, and then it's kind of convenient to have this. So let me cover the what we are going to talk about here. So I'm going to mention about the what that is as an introduction, and then we also see the example. Then we are going to go deeper into the concept of the DeepQ network, and then we also see the implementation because it's easier to have the idea of what that is, right? So in the implementation, we prepare the Python code, which is the normal Python program, and also we have Jupyter Notebook. So yeah, let's start with the introductions. So the DeepQ network (DQN) it's one of many reinforcement learning algorithms which uses a neural network. So neural network is something people call deep learning. So some people like to say this is deep reinforcement learning. So originally this was proposed 2013 by DeepMind, which is the company under the Google AI company in the UK. In the paper shown here, the Atari means it's a name of game. So the I want we want to cover this topic. It is because this DQN is it's cool because it's learning from scratch without human interventions, and sometimes the result is better than the human being. So, but at the same time, many papers of reinforcement learning using the DQN as a benchmark. So even though this is a 2013 idea, when you look at the paper from 2018 or 17, they mentioning DeepQ network, and then researcher like to say our new algorithm is, for example, 2 times better in computational performance or something as a benchmark. So I think it's a good idea to know about the what the DQN is. So we are gonna take a look at the examples. Example is a Space Invaders, which is something shown in this slide. It's a game that you have a game screen, and then the thing is not shown here in the image, but the someone is you have to move that thing, move left or right, and then you try to kill the enemy, and then the goal of this game is you kill as many enemies as possible, and then you try to achieve the higher result. So the idea is because this is an image, so you use the convolutional neural network to process the image and then output what you have to do. So there is a link. I want to keep this video as short as possible, so you can watch it later. But this is the example that is motivated that reinforcement learning is very cool, DQN is very cool, so we want to know more about this the algorithm. So I'm going to just skip to the concept of the DeepQ network. So I want to focus on the big picture in this video, not paying too much attention to the detail. So the big picture is something you have the framework of the reinforcement learning, and within this environment you decide in the action, and then if you take the action you can go to the next stage, and then you have a bunch of data, so why don't you just collect those data, and then if you have a collection data we can train some sort of model. And then you finish this one iterations, the next state is going to be our current state, and then we just repeat this process. So maybe you can think of DQN is some sort of for loop, repeating a sequence of processes, and then we believe that within this many iterations we are going to have the model, we are going to have a good model which is going to be converged to the optimal model after many iterations. So for each component, we have several major ideas. We are gonna cover three major ideas. One of the things is Epstein greedy algorithm, so which is the algorithm to decide how to get the actions. The second thing is experience replay. That's the idea for how we are collecting the data. And then the most important part is it's called Q-learning, which is the idea which exists to train our model. So we are going to maybe you can forget about my very lengthy talk. I don't want to waste your time. So maybe why don't you just focus on those kind of keywords, and then you just get the idea. Reinforcements is something like this, because this is just a short video. So let's focus on the big picture. So from the Epstein greedy algorithm. So I put the image on the slide. So why don't we just set the some threshold called epsilon, for example 0.1, which means 10%, 1 out of 10 actions we are gonna follow the random action, but 9 out of 10 we are gonna listen to the model outputs. So yeah, so that's it. That's the idea of the Epstein greedy algorithm. So why do we do that? It is because at the beginning of learning, because we're using the neural network in the model output in the model, neural network always can produce something with the data, but at the beginning of iterations, maybe the model, because the agent haven't experienced so much within the environment, model can produce something, but maybe the output is just the locally optimal. So we wanna force the agent to try to go to the different state within the environment. So if you have the Epstein greedy algorithm, we can force the agent to do something new, and then you learn more. So that's the kind of benefit of this algorithm. So I shown the algorithm here, but we're going to see the Python program later. So I'm going to skip here for the moment. So the second idea is how to collect the data, which is the experience replay idea. So you can look at the image on the slide. So why don't we have kind of collection? You can think of, in the Python language, it's just a list. If you more familiar with the Java, this is maybe think of as it's a array list. It's a memory of experience. Some people like to say this is a buffer. So for example, we have the size of 1 million buffer replay memory, and then within this capacity of replay memory, we just put in the set of data. Always it's state, action, reward, and next state, and then we are collecting those data sequentially. We can do that because we iterate in the environment sequentially, and then sometime we are going to get the data from this replay memory, but we just get the mini batch. For example, the size is 32, and then as you can notice, the t is a random number. So in the replay memory, we collecting the data sequentially, but we just randomly get the small subset of the data, and then we pass that data to the neural network to train. So that's the idea of replay memory. So there is a benefit to do this. The first thing is it's efficient. So if you're using the replay memory, we can store a large size of data. But when we train a model, we only get in the mini batch, so we can efficiently train our neural network model. So that's the one thing. And the second thing is I already mentioned, but we can reduce the correlation between the data. So the point is, because we sequentially collecting the data, T1 state, T2 state,